Titan may have rewritten Saturn's system. Fresh simulations link one ancient collision with Hyperion's strange shape, Iapetus's tilted path, that 27-degree planetary lean, plus those young rings. Suddenly, this giant moon isn't merely circling a world. Its gravity could explain why everything nearby looks so unusual today. Here's the wild part. Researchers still can't prove their violent chain happened exactly as modeled. Some clues survived, others vanished. Cassini left measurements keeping mystery alive, while future evidence might flip our picture again. Before we trace cosmic wreckage, drop your country below. Now watch how chaos possibly changed nearly all forever somehow. Somehow the first clue was hiding in the brightest thing around Saturn, its rings. Cassini showed that those shining bands are made of 8% water ice, yet their total mass is surprisingly small. That matters because space is dirty. Tiny rocks and dust keep hitting the ice, slowly staining it darker. If Saturn's rings had been sitting there for billions of years, scientists expected them to look far less clean. Instead, their brightness pointed toward something shocking. They may have formed only 10 to 100 million years ago, long after dinosaurs had already appeared on Earth. So the obvious question became simple: what happened? One old idea offered a brutal answer. Bring a moon too close to Saturn, and the planet's tidal pull can become stronger than the gravity holding that moon together. Cross a boundary called the Roche limit, and the body can be torn apart. Its remains may spread around the planet, creating a ring. That sounded almost perfect. Then scientists tried to find the missing victim. In 2022, researchers at MIT proposed an extra moon named Chrysalis. Their model suggested Titan's gravity could have disturbed Chrysalis, pushing it towards Saturn until the lost moon broke apart. Suddenly, the young rings had a suspect, a weapon, and a possible chain of events. But here's where that neat story started falling apart. A different team ran new simulations and published its results in February 2026. When they tested the Chrysalis idea, the missing moon usually didn't fall towards Saturn at all. It was more likely to smash into Titan. Most debris would then be caught by Titan or thrown away, leaving too little material to build the rings we see. One problem had become two. Something else kept going wrong inside those simulations. Hyperion, Saturn's small, oddly shaped tumbling moon, was often lost during the chaos. Sometimes it disappeared from the system completely. Look at Saturn today, though, and Hyperion is still there. That survival changed the investigation. Hyperion isn't just another moon floating near Titan. Their orbits are locked together in a repeating gravitational rhythm. Matija Čuk and his collaborators noticed that this relationship appears young, dating to roughly the same broad period when the proposed upheaval may have happened. That meant Hyperion might not simply be a lucky survivor. It could be evidence left by the disaster itself. Think about what that does to the mystery. Scientists began with bright rings and searched for something that died. Instead, they found a living moon telling them their first collision story was incomplete. So the team stopped asking only, what made Saturn's rings? They widened the question. What single chain of events could explain Hyperion, Titan, Iapetus, Saturn's strange tilt, and those young rings together? That shift led them toward a much larger lost moon. The next simulations would turn that clue into something more violent than Chrysalis ever suggested. And this time, Titan wasn't standing beside the crime scene. It was directly in the middle of it. Once researchers widened the search, Hyperion stopped looking like a survivor and started looking like a clue. Matija Čuk and his team tested a bigger body they called proto-Hyperion, a lost moon about 4 times more massive than the earlier Chrysalis idea. Proto-Titan was different too. It was smaller, and its path around Saturn was more circular than Titan's orbit today. Then the numbers became hard to ignore. Across 60 simulations, Proto-Hyperion collided with Proto-Titan 42 times. In many runs, where that crash didn't happen, either Proto-Hyperion or Iapetus was thrown from Saturn's system. Yet Iapetus is still here, and so is Hyperion. That made the linked collision path especially interesting. If you're enjoying this mystery, subscribe now, because the next clue changes Saturn itself. To understand why those moons crashed, we have to go back roughly 400 million years. Saturn had slipped out of a repeating gravitational rhythm with other planets. That shift helped disturb Proto-Hyperion till it entered a powerful 2-to-1 resonance with Proto-Titan. Here's what that means. For every single trip Proto-Titan made around Saturn, Proto-Hyperion completed 2. Each pass added another tiny gravitational tug. One pull meant almost nothing. Thousands upon thousands could reshape an orbit. Soon, Proto-Hyperion began moving inward, but it wasn't falling quietly. As its path changed, the moon also tugged on Iapetus, helping push that world into the highly tilted orbit scientists see today. One strange feature of Saturn's system suddenly had a possible cause. More importantly, Proto-Hyperion kept drifting toward Proto-Titan. Their paths were crossing. Imagine 2 cars circling different lanes, while one lane slowly slides into the other. Nothing happens at first. Then the gap shrinks, Every lap raises the danger until avoiding contact becomes almost impossible. Space works more slowly, but gravity doesn't forget. Eventually, the two proto-moons met. The impact was enormous. Much of proto-Hyperion may have merged with proto-Titan, making Titan larger. Other pieces could have gathered together again, forming the smaller Hyperion we know now. That would help explain its loose structure, odd shape, chaotic spin, and apparently young age of roughly 400 to 500 million years. Suddenly, Hyperion's survival wasn't a problem. It was evidence. The collision could also help explain why Titan's surface looks younger than expected. Cassini and Huygens revealed relatively few impact craters there. In this model, a giant crash could have resurfaced large areas, wiping away part of Titan's older record, yet that still wasn't the biggest consequence. The impact changed Titan's orbit, leaving it far less circular. Tidal forces then kept pushing the enlarged moon outward from Saturn. Several unrelated puzzles were becoming one connected trail. A tilted moon, a battered survivor, a younger surface, and Titan's altered path could all point toward the same moment. Then one measurement made the story harder to dismiss. Cassini later measured something remarkable about that escape. Titan is moving away much faster than scientists once expected, and that motion may have changed the giant planet itself. Cassini found Titan moving away from Saturn at about 11 centimeters each year, much faster than scientists had predicted. That sounds tiny. Your hand is wider than the distance Titan gains in 12 months. Across millions of years, though, a small drift can become a force that reshapes an entire system. After the ancient collision, Titan's orbit had already become stretched. As the enlarged moon kept moving outward, its gravity changed the way Saturn behaved. Saturn doesn't spin perfectly upright. Its axis leans about 27 degrees, a strange angle for a giant planet expected to form with very little tilt. Scientists have long wanted to know how it got that way. This model offers a remarkable answer. Saturn is not a perfect ball. As it spins, the planet bulges around its middle, while gravity from the sun and moons makes its axis slowly wobble. Picture a spinning toy top beginning to lean. That slow wobble is called precession. Titan may have changed its speed. As the moon traveled farther away, its pull altered Saturn's wobble until the planet's spin became linked with Neptune's orbit. Another resonance had appeared, except this time, the dance wasn't between two moons. One partner was a planet. To keep that gravitational lock while Titan continued moving outward, Saturn had to tilt farther. Over immense stretches of time, the same moon that may have survived a huge collision could have helped drag a giant world toward the angle we see today. Stop and think about that. Titan is only a moon, yet this scenario connects its migration to the lean of a planet more than 90 times wider than Earth. A change that began with orbital chaos may still be written across Saturn's whole body. That's the strongest clue in the story because it reaches far beyond one damaged satellite. The model isn't trying to explain Hyperion alone. It links Iapetus's tilted path, Titan's changed orbit, Saturn's wobble, and several events separated by hundreds of millions of years. Still, this isn't proof. A simulation can show that a chain of events works without proving nature followed that exact path. Researchers need observations that match predictions, and another model could someday explain the same clues differently. For roughly 200 million years after the first disaster, the system appears to have settled down. Titan kept drifting anyway. Quietly, year after year, its orbit expanded. Nothing dramatic needed to happen quickly. Gravity had time. Then, about 100 million years ago, Titan reached another dangerous orbital relationship. Its path became locked in a 4-to-1 resonance involving one of Saturn's inner moons. The balance broke again. For ages, those inner worlds had circled safely. Now their paths began shifting, slowly at first, then enough to turn stable motion into real danger. This time, Titan wouldn't need to hit anything itself. Its gravity could push two smaller moons toward each other. What followed may have created the most famous feature Saturn has. About 100 million years ago, according to the model, Titan's expanding orbit entered a 4-to-1 resonance involving one of Saturn's inner moons. That new rhythm didn't stay harmless. Titan became tilted, while the paths of two smaller moons began to shift under the changing pull around them. Eventually, those inner moons collided. Their destruction was only the beginning. The crash produced a huge cloud of broken material, but Saturn was waiting underneath. Its tidal forces pulled at the wreckage, stopping much of it from simply gathering back into the same bodies. Some pieces escaped, others slowly joined together and formed new moons. The rest spread out. Bit by bit, shattered ice settled into a thin disk around Saturn. Those remains may be the rings. That idea changes the way you look at them. From Earth, Saturn's rings seem clean, calm, almost perfect. In this scenario, they're closer to a graveyard, made from debris left after a chain of orbital changes that Titan helped start. Remember the mystery from earlier. Cassini found rings made almost entirely from bright water ice. Their low mass and clean appearance suggested they couldn't have been sitting around Saturn since the solar system began. Now the timeline had a possible cause. A collision around 100 million years ago fits far better with young rings than a system built billions of years earlier. Titan didn't have to smash into those inner moons. Its changing orbit only had to disturb the balance enough for gravity to finish the job. That's what makes this story so unsettling. Nothing here needs a monster asteroid arriving from deep space. No wandering planet has to tear through Saturn's neighborhood. The danger can come from inside a system that already looks stable. One moon moves, another orbit shifts, a resonance forms, then worlds collide. Yet the rings weren't the only things left behind. Some debris gathered again, creating new moons, while other material stayed spread across Saturn's orbit. That means the beautiful system we see today may be partly built from the remains of an older one, and Titan kept moving. Even after the crash, its slow trip away from Saturn continued. The moon that may have helped reshape Hyperion, disturb Iapetus, alter Saturn's wobble, and trigger another collision didn't stop when the rings appeared. So researchers stepped back from each mystery and looked at the full picture. That's when the pattern became difficult to ignore. Iapetus has its strange tilted orbit. Hyperion looks young, loose, oddly shaped, and spins in chaos. Titan has a youthful surface, a stretched path, and an unexpectedly fast outward drift. Saturn itself leans about 27 degrees. Then there are those bright young rings. Each clue once looked like a separate problem. Put them together, and something remarkable appears. One violent history may connect almost all of them, but a model that explains everything can still be wrong. And scientists now need a way to test it. That may sound simple, but Saturn is almost 1 billion miles from Earth, and the clues scientists need are spread across moons, rings, and events that happened hundreds of millions of years ago. Nobody can rewind the system and watch those collisions happen. They can, however, look for scars. Titan may hold some of the best ones. The giant moon is wrapped in thick, nitrogen-rich air, with methane clouds, rain, rivers, and lakes shaping its surface. When Cassini carried the Huygens probe there, scientists saw a world far more active than a frozen moon should look. Even stranger, Titan has relatively few impact craters. Its surface appears young. That matters because the collision model gives scientists a possible reason. If proto-Hyperion slammed into proto-Titan roughly 400 million years ago, the impact could have resurfaced large areas, covering older ground and wiping away craters that had built up before the crash. Finding signs of that past could strengthen the story. Luckily, something is already coming. NASA's Dragonfly mission is designed to send a nuclear-powered rotorcraft to Titan. Instead of staying in one place, this car-sized machine will be able to fly, land, collect data, then move to another site. Its instruments will study the chemistry of Titan's surface and atmosphere across different locations. That's important for more than one reason. Dragonfly isn't being sent there simply to prove that Titan changed Saturn. The model could still be wrong, and one mission can't replay an ancient collision. But evidence of old resurfacing may help researchers test whether Titan's ground carries signs that fit a violent past. Now the mystery has a deadline. Dragonfly is scheduled to launch in 2028 and reach Titan in late 2034. For years, scientists have had to work backward from Cassini measurements, orbital patterns, strange moon shapes, and computer models. Soon, they may get new clues from Titan itself. Picture that moment. A flying machine lands on a moon that may have survived one of the most important crashes in Saturn's history. Beneath it could be ground shaped by methane rain, hidden geology, and perhaps traces of changes that began hundreds of millions of years earlier. Still, researchers aren't waiting for one perfect answer. Chook and his co-authors make an important point. Even if their exact sequence isn't confirmed, the model can guide new ideas about how Saturn's moons evolved together. That's science working the way it should. A strong explanation doesn't end questions. It creates better ones. Resonance, tides, and precession aren't new forces. Scientists already understand those basic pieces. What's surprising is how those familiar effects might connect across huge spans of time, turning tiny orbital changes into collisions, new moons, a tilted planet, and rings. But there's another clue we haven't finished with. Saturn's rings aren't frozen evidence of an old disaster. Cassini discovered they're still changing right now. And what is happening to them today makes their violent origin feel even less like ancient history. During Cassini's final dives, the spacecraft slipped through the narrow gap between Saturn and its inner rings. Those passes weren't just a dramatic ending to the mission. They let scientists measure a system that looks permanent from Earth, but is actually losing material every second. Ice is falling out of the rings. Particles constantly bump, shift, and interact. Some eventually drop into Saturn's atmosphere as a steady rain. According to the Cassini data in this story, that loss can reach up to 40 tons every second. That number changes the picture again. Saturn's rings may look huge, but they don't have an endless supply of material. If they keep losing ice, they can't remain bright forever. Scientists estimate they may survive for only a few 100 million years more. So we're looking at them during a special window. They weren't always there. They won't always be there. And right now we happen to live between those two ends. That makes the Titan idea even more striking. If the proposed chain is close to what really happened, then Titan helped push Saturn's system from one version into another. An older set of moons was disturbed. Collisions followed. New bodies formed. Debris became rings. Those rings are now slowly disappearing. Nothing about this place is still. Scientists sometimes describe the Saturnian system as a dynamicist's paradise because gravity keeps linking everything together. A moon doesn't simply travel around a planet without affecting its neighbors. Tiny pulls build over time. Orbits shift, resonances appear, stable patterns can break. Titan is still moving outward too. That means the story hasn't reached its final page. Think back to where we started. Saturn looked like a peaceful giant surrounded by perfect rings. Then each clue changed that image. Hyperion pointed toward an ancient crash. Iapetus carried evidence in its tilted path. Titan's orbit suggested a violent change. Saturn's own lean may record another stage. Finally, the rings could be wreckage from a later collision. One system, many scars. Yet there's a danger in how perfectly those pieces seem to fit. A model can connect several mysteries and still miss part of the truth. Scientists haven't watched these ancient events happen. They're rebuilding a lost history from motion, surfaces, ages, shapes, and physics. That leaves one huge question open. Did Titan really drive this entire chain? Or are researchers seeing several different events that only appear connected? Dragonfly may help with part of that answer. But Titan isn't the only place holding clues. Every strange orbit and surviving moon gives scientists another test. The better this model becomes, the harder those tests get. Because explaining Saturn's past isn't enough. A truly powerful idea must predict details we haven't confirmed yet. Those future measurements could either strengthen this beautiful chain or expose the missing piece completely. And one of the strangest clues may be hiding in the system we see today. That clue is Hyperion. At first glance, it hardly looks important enough to challenge a story about Saturn's whole system. Hyperion is small, misshapen, low in density, and constantly tumbling. Yet those odd features are exactly why researchers keep coming back to it. If this moon formed from loose debris after the proposed proto-Hyperion collision, then its present body may be a surviving piece of that ancient event. Its age matters too. The source places Hyperion at roughly 400 to 500 million years old, close to the period when the first major collision in this model may have happened. Its strange shape fits a body assembled from weakly bound fragments. That wild rotation could also carry momentum left from the crash. Then there's its relationship with Titan. Today, Hyperion and Titan sit in a 4-3 resonance. Their paths aren't random. They move in a repeating rhythm, and researchers argue that this lock is relatively young. In other words, the moon that looked like a problem for the older chrysalis idea becomes something much more useful in the newer model. It becomes a witness. But Hyperion isn't standing alone. Iapetus gives researchers another test. During the proposed chain, proto-Hyperion moved inward after entering resonance with proto-Titan. On that journey, its gravity disturbed Iapetus and helped push the moon into the highly tilted orbit we observe now. One event could leave two different scars. That's why this model has gained attention. It doesn't solve one mystery by ignoring the others. Instead, researchers built a wider picture where each surviving object has to end up somewhere that matches what telescopes and spacecraft actually see. Still, matching today's system doesn't prove every step. There were 60 simulations in the study described by our source. A proto-Hyperion and proto-Titan collision happened in 42 of them. In runs, without that impact, either proto-Hyperion or Iapetus was often thrown out of the system. Those results make the collision interesting. They don't make it certain. The difference is where the real mystery lives. Scientists have a chain that can connect events spread across hundreds of millions of years, but nature left no recording of what happened. Researchers have only the pieces that survived. Titan may be the biggest piece of all. Its youthful-looking surface, thick atmosphere, stretched orbit, fast outward movement, and gravitational link with Hyperion all sit inside this proposed history. Add Iapetus, Saturn's tilt, and the young rings, and the pattern becomes hard to look away from. Yet one question remains: if Titan really changed this much, what happens next? Because its outward journey hasn't stopped. The rings are still losing material. Gravity is still working. Every orbit adds another tiny pull, and over enough time, even a calm system can become something different. Saturn's system is still changing, and that means the final part of this story isn't buried 400 million years in the past. We're watching it happen now. Titan continues moving away from Saturn, while the rings keep shedding the ice that makes them shine. Neither change feels dramatic on a human clock. You could spend your whole life watching Saturn and never notice the system shift. Give gravity millions of years, though, and everything changes. That's the lesson hiding inside this story. Scientists already understood tides, resonance, and precession before this model appeared. None of those forces is new. What surprised researchers was how those simple effects could work together across huge stretches of time and possibly explain so many strange features at once. Start with Titan. Roughly 400 million years ago, the model suggests proto-Titan collided with proto-Hyperion after their orbits became dangerously linked. That crash may have enlarged Titan, changed its path, resurfaced parts of the moon, and produced the Hyperion we see today. Then follow the damage outward. Iapetus was disturbed. Titan kept migrating. Saturn's wobble changed, its axis tilted. Later, another resonance upset two inner moons, which collided around 100 million years ago. Their broken remains may have spread into the bright rings surrounding Saturn today. One moon sits near the center of that chain, Titan. But scientists still can't say this is exactly what happened. That matters. The February 2026 study offers a model that brings many strange observations together, yet researchers still need evidence capable of testing its history. Another explanation could eventually fit the clues better. Dragonfly may uncover signs that support Titan's resurfacing story after it reaches the moon in late 2034. But even that won't replay the ancient collisions for us. Some questions may stay open for years. Others could grow stranger. Saturn's rings are already fading as material falls toward the planet. Titan keeps pulling away. Hyperion continues tumbling through space. Iapetus still follows its tilted path. Every object carries part of a story whose beginning nobody witnessed. That's what makes Saturn different once you know this. Those rings stop looking like decoration. They become a clock. Their bright ice tells us we arrived during a short chapter when they exist in this form. Hundreds of millions of years earlier, Saturn may have looked completely different. Hundreds of millions from now, another observer could see a world without the same brilliant bands. We got the middle. Maybe that's also why Titan matters so much. From a distance, it appears to be another moon moving around a giant planet. And look closer, and its gravity may connect a collision, surviving debris, tilted worlds, changing orbits, Saturn's lean, and the creation of its most famous feature. Scientists now have a possible story, but what they don't have is the final answer. Until new evidence arrives, Saturn remains a crime scene shaped by gravity, with Titan standing at its center. And somewhere beneath Titan's orange haze, the missing proof may still be waiting. Saturn's rings, tilted moons, and battered worlds may trace back to a giant. Dragonfly could uncover the clue